Hey everybody, this is Larry. This is me doing virtual contest weekly contest 250. Okay, whatever. This is me doing a virtual contest, so you can see me do this live. I haven't seen the prompts yet, for the most part. Well, I mean, I haven't seen it today anyway. Like maybe they have duplicate prompts. I don't know why I'm rambling. Yeah, hit the like button, hit the subscribe button. Join me on Discord where a lot of people discuss the contest right afterwards. It's a fun atmosphere, though. Today I couldn't be there live, but usually I'm there live. So yeah, yeah. Okay, am I ready? Let's click on the start button and let's go. Okay. I haven't done a virtual contest in a while, so I don't even know how to do the intro. But let's get started. Am I recording? Yeah, I am recording. Okay, had to double check. Okay, malfunction. Return the number of words in text that you can. Okay, should be straightforward. Text not spring. Oops. If or C not for C in Word, C not in S, then count. I know I have to. Okay, hopefully this is good. It should be close, but I don't have my mouse, so it's a little bit awkward as well. 110 is such a bad thing, though. Let's see. Like it doesn't give me confidence, and I've been doing this thing where I'm slowing down a little bit to make sure I get it correct, because 5-minute penalty is pretty expensive. Okay, so hello code is what I expect to print out. That is what I'm printing out. So let's go. Also, this is not real, I guess, so that's why I'm a little bit, I probably would have submitted already during the contest, maybe. I don't know. Let's see. Give it a submit. Okay, that's good. Okay, add minimum number of rounds. You're given a strictly increasing height of your current on 40. You want to reach the last one. You're given an initial distance. If the distance between where you current at and the next one is at most, say what? Okay, let's see. Current cannot reach the last one. Add ones at 7 and 8. Okay, so you want to add stuff. I mean, this is going to be greedy. For sure, this is greedy. Do you start at 0 or 1? You're at 0, okay. And what's distance again? What am I doing again? Okay, so distance is the number of steps that you can jump, and you want to get to the last one. Okay, so this is for sure greedy. I was going to see if I need to sort it. It's already strictly increasing, so I'm okay there. And I'm just going from left to right, and then yeah, okay. So yeah, okay. So now we just have to look at adjacent ones. Where is the 0? So we start at 0. So let's just start at 0 then. So I know that I'm writing this this is technically linear, but I think it is a linear algorithm anyway. So for A, B, and zip of rungs, once some so adjacent elements, count B minus A round down, I think. Let's see, if there's 5, I think I have to minus 1, but if it's 2 exactly, it's none, okay. I think this is this, but I could be wrong. It's strictly increasing. I think let's also set this to in case that it gets negative for some weird reason, but let's run it real quick. Oh, well, I should return it. Run it real quick. 2010. I think this is okay. I don't want to rush it. That's why I'm thinking about it. Even though I think this is mostly okay, I'm just trying to think about the edge cases. I think this is okay though. And that's up and off by 1. That's the only thing. Let's give it a spin. Okay, that's good. Okay, Q3. Maximum number of points with cost. You 1 cell in each row. However, you lose points with 2 cells on the previous row. For every 2 adjacent rows, picking cells at what? Okay. So this is 3, 5, 3, and then you must subtract one distance on distance. Okay. This is awkward. This is just gonna be D. Hmm. I mean, this is DP. Greedy. This feels like something I've seen, but it's okay. So go here, here. Okay. Yeah, no, it's DP, but I feel like I have to do a transformation somewhere to kind of make the math a lot easier. Cause yeah. No, because if you're sloppy, you have two rows of 10 to the fifth over 2, and that's just not quite ideal. I must subtract. Like, this is some like weird mono Q, maybe. Is it? Max of that minus. Like I'm getting some vibes with sliding window and whatever, but okay. Slow down, Larry, and then think. Okay, so you do one scan on the first number, and then you have 0 and then next you subtract everything on the right by on the next one you add no, you get closer, so you get one more benefit and you add everything to the left. How do I phrase that? And then you get the max of those two components, right? Okay, so the effective score would be -1, -2, and then we factor that in, and then as we move shift, then you add everything on this thing to the right. Okay, I think I got it. It's a little bit awkward to think about though. So, okay, let's see. Yeah, I feel like there's a lot of potential mistakes, but I think this is okay. So let's do it. Rows is equal to length for points. Columns is equal to length for points of 0, maybe. Yep. Okay. I'm just looking for zeros. Okay. Maximum points you can achieve. Are these all odd numbers? Oh, not odd numbers, but positive numbers. I'm just trying to think whether there could be negative contribution from the previous row, and I think that the answer is no, because at worst they're all zeros, and then if they're all zeros, then you just take the row previous, and yeah, and then just take that. So okay, so then now we have I'm trying to think. So what I'm thinking right now is that I think we can use two heap type things, or sorted list in my case, to be honest. But I'm also just trying to think whether it makes. I think there is like a mono queue type thing, but on a contest, and I am on a contest, even though it's a virtual contest, I'm not gonna spend time on that. So let's do that. So okay, so let's start off by on the first row. So okay, scores is equal to times columns for the first row. For the first row, we go for the best score because we don't have any negative score, so that's just the base case. So then the base case is for C in range of cars, row sub 0 of C scores. Oops, my S key is weird. Let's go to okay, right? And then now we go okay for R in range of 1 to rows. Yeah, okay, I think we're good. And then here we want to go new or next score, maybe next scores is equal to I guess we could actually just why did this is not even a thing, but okay. But I can actually set this already to just points of 0. So I don't even need this. I know that I manipulate the input now, but that's fine. I'm lazy. So then this is points of R. And then now we look at the previous row as we said, and we want to pre-process it. Yeah, okay. So then now for previous row, let's say if for C and range sub cars, was it score sub C? We want to subtract that by C. 0, yeah, okay. And then now we want to do, what do we want to do, Larry? Yeah, and then now for C and range of comms, we do next scores of C. This is equal to, or this is, we add this to the previous best scores on the left and on the right. So let's actually set left is equal to sorted list and right is equal to sorted list. I hope this is not too slow from import sorted list. And then here we want to get the max of, so the max of the left and the max of the right. Oops. So this is going to be the max of the, I don't know why I typed this backwards, but it's too late. Yeah, and then at the very end, we just scores is equal to next scores. And also, let's just do best is equal to 0. Best is equal to max of scores. Though I think we don't have to do this on every iteration. We have to return best. Now we have to do the, for everything, we have to slide. So after we, yeah, okay. So now after this, we want to slide. How do we want to slide? Like the electric slide. Also, this is not sufficient. We actually want this to be scores. Yeah, okay. And then now we want to do a slide. We slide, but oh, and this is actually a little bit wrong. No, well, in the beginning it's right, but we have to do an offset. So the offset is that when we shift, when we go one to the right, when we go to the right, we actually add C, and then as we here, we subtract C because we're moving away from it. Does that make sense? Yeah, okay. No, I think this makes sense. But then now we have to shift some stuff. So now after we did the math here, then what is the change? The delta is, as we go to the right, then we take score sub C, we take this and we put it into left. So left dot add this. Is that right? Is this right? Anyway, and then right we would remove, we would pop off. Am I doing this right? Yeah. I mean, I have all the ideas, but I think I'm just handling things a little weirdly. So we have 0, -1, -2, 3, and we shift. Well, so then everything to the right is the same, except we want to add a number. And everything to the left is subtract 1. I guess that's right. I think I'm okay with this. I may be off by 1, but I think this is roughly what I want to do, though. Okay, our range. Where am I our range? Oh, this. Oh yeah, because this might not have an element. Like left doesn't have any element yet because our default is that column sub C is to the right. Okay, so how do I type this in a smarter way? Okay, whatever. Let's just do it the dumb way. Score is equal to right -1 plus C if length of left is greater than 0, and left of minus 1 minus c is greater than score. Score is equal to left. This is a little bit yucky, but that's okay, right? No? Oh no, max score. Oh, scores. Typo, typo, typo. Oh no, pay to win. Okay, let's see. 9 and 11, is that right? 9 and 11. Am I confident about this? I mean, doing a contest. Oh, this is doing a contest, so you don't get any answer anyway. But what else can I test? I guess I could test the one case, one column and one row. I think that's a reasonable case to test. That's one column, one row is. So that's kind of make sure those are working. 10. Okay, so this is clearly not working, which is great that we test this. But okay, so 1 plus 2, but that should be 10. Okay, so why is one row not working? Oh, because we skip this on here. So that's okay. Let's add that here. That's why we test things. That's why we're still sad, because we put the pass is equal to 0 afterwards. Okay. But I guess we don't even need this. So that's whatever real quick. That's why we test code. Let's give it a submit. Fingers crossed. Hopefully it's not too slow. That's my only concern, because these are log n type things. If it's too slow, I'm going to be a little bit sad. Maybe a lot sad. Oh, okay. Wrong answer is even sadder. Okay. Why is this wrong? I put 14, but 15 is the optimal answer. Why is it 15? That's yikes. Let's see. Okay. So I have 14. Why do I have 14? What is the optimal answer? Is there greedy? Let's say 4, 4, 5 is already 14. Right? But here, if we have 4, 4, 5, 3, it should be. So this has a contribution of 2. Oh no, that's only 13. So that's 15. Okay, so 4, 4, 4, 4, 4, 5, 3 is the answer. But I do. What do I do? Ding dong dong. What do I get? So I have. Okay, skipping the first row. We have some 11, 14 is here. That's a little bit awkward. Is that an actual path though? Previous is 12. What is going on here? 7, 12. Something is really weird, because I have a 7 here. No, did I really mess up? I really messed up, didn't I? Because this is the first row. How did I even get a 7? So okay. Something is just really weird. Yikes. Okay, let's print that out as well. For the previous row. So this is the previous row, right? So then sums it up to get here, because now this is 2. So 3 going to 5 is 7. Actually, that's correct. So 3 going 5 to 5 to 2, is that right? That is 12 plus 3 minus 1. Okay, so I could see 14 being a possible answer. So we're correct there. So why are we wrong on the 15 though? Well, let's see. The 4 to 4 to 5 should be 13. So we should have a 13 on the second to last row, which we do. Right? Yeah. Okay. So then why is 13 to 11 really bad? Dun, dun, dun. Yeah, why is that? Man, maybe I have some weirdness. Maybe I have some weirdness. Also, I'm being really dumb with the optimization, at least on the left side, because the left side doesn't have to be a sorted list. You just get the max, right? So we can optimize that away. Though running time is not really the issue. And even on the right, maybe right side is fine, but okay. Yikes. So 13 here is right? Because it's 4, 4, so this is 8. That's good. And 8 plus is 13, which is good. Yeah, so then here, once we're here, what does that do? This is 10 plus 4, 10 plus 3. Do I have it off by 1? 1, 2, 3. No, 10 plus 3, so this is 13 plus. No, I think my light just got dimmer. No, I think I think I handled the left side incorrectly. I think this has to be because I'm adding 10 to the left, but it should not be 10, right? Am I double subtracting this? Is that right? That's the offset. I'm handling the left side a little bit weird. I know. I think that's why, but because I add this here, but I think I need to add the left as this, but something else. Someone's messing around with the lights for some reason, but because when I add left, I'm adding the 10, and then the 10 immediately gets a subtract score because it's on the left. So I think I'm handling the left side incorrectly. Right? So, okay, so I subtract 1. We want the second number to be subtract 2. I think I'm just handling the left side really incorrectly as part of the shift. And why is someone like messing around the lights? Come on. Okay, so anyway, we have this number. That's all on the. This all begins on the right side, and as we see to the left, this one should be. Plus 1. I'm only thinking one number. Second. Why is this so weird? Okay. So we have 12. Okay, it starts at 12, and then it should be 11 after one step, and then 2 is 10, 9. So that's how I got the number. So that part is right. But then we have on the second number, maybe that's where I fail. I mean, that's definitely where I fail. But I'm really bad at arithmetic. So we start at 6, and then as it gets closer, we add it. Let's say this is just plus C. Did I already press the button? I guess I did, but that didn't do enough. Yikes. Let's. How do I want to debug it? Maybe that's another way. Let's see. C, left, right. So okay, so yeah, this has nothing, has this thing, and then now it has 12. Yes, the second number is 6, but it really shouldn't be 6, because it's 6, and then, so it started out 6 on the right side, with an offset of, what am I doing? Poop. So then after we shifted over 1, this is, why does this plus C not fix it? Yeah, so this is 13, but then now everything is on the left minus C because of how we do it. Because 12 should be minus C, but 7 should be this minus, so one step away should be minus 1. I'm not factoring that. Maybe I don't need this. No, I'm doing this in a really weird way. It's something like this, but I'm really bad at math right now. I guess this is just like a real contest. I'm struggling like painfully. Okay, so 12 goes to the left. This should be 11, which is fine because now there's an offset of 1, right? And then the next one, that's a 2. So now 11 should be 10. So for that number, that's right. But but I cannot minus 2 on every number. That's where I'm wrong. This is where I'm wrong. How can I fix this padding? So the longer you stay, I think I definitely need. So okay, but this plus C is at the time it is. Yeah, that is the beginning number, but I cannot minus everything by that number because this is minus 1. I don't know what it is. This is minus 1, this is minus 2, this is minus 3, this is minus 4, but I do minus 4 on everything. That's why this is wrong. So then I just have to offset. I was thinking about this, but I wasn't sure that this would be enough. Maybe minus 1. 9, 11, 10. Maybe that's it. And I was thinking about this, but I was very not confident about this. What is this 6 referring to? 6 is 1, 2, 3, 4, 5, 6. Okay. Let's give it a go. I feel like this is roughly right, but I don't know, to be honest. I'm very not confident now. Let's actually double check real quick, because these scores should be the best score on the last one. So this is 15 is right, 14 it should be right, 11. So this is 0. So this would be taking this and then minus 1. So I think that's right. 13 is 1 plus this 13. So this is right. I think this is, well, it's right for that test case. Let's give it a submit. Okay. What a sloppiness. Okay, let's go. Q4. Let's refresh real quick, as I usually do. Though usually I refresh to kind of see how hard it is. So that's kind of, and we could spend some time refreshing this one to kind of just see how hard it is in my current time. Some people already finished. Okay, so I'm not that far behind, though I really should have gone Q3 earlier because I have most of that math. But okay, Q4. A lot of people did it in 10 minutes, so I probably will have to spend some time. Okay, maximum genetic difference query. Let's see. Generic, each node's number is its unique genetic value. The genetic difference between two genetic values, the bitwise. Okay. What does that mean? Okay. For each query. Okay, what is going on? So, okay, so we have this tree. Let's see. This is a lot of, I have to think about this. It's a little bit late in the night. The node of the, okay. I have to slow down and really read this. Okay. Okay, so the difference is XOR. Each node has its value as an X. Okay, the parents I know. What's a query? Find the maximum genetic difference between Y and P sub I, where P sub I is the genetic value of any node. It's P sub, okay. And the root on the path between, okay, so we're given node and the root. Wait, what? The node. Okay. So basically, if I mean, I'm sure that the constraints that um, are weird enough that you cannot do this brute force. But the brute force way to do it is, this is very hard to read, but you find a node and then you just keep going up. Like you basically have a list. You do the maximum. You do a a max over the XOR of all the things to the number. Okay. Mm. Okay, let's look at the constraint to see anything I can abuse. Well, the numbers look pretty okay. I mean, this is a tree. Oh no, well, you have to construct a tree. And you have, well, I guess half an hour in, only 9 people got it right. And even people who are really fast on Q3. So, okay. Let's see. So, okay, so let's say 4. Where's 4? 4 is there, 6. You just go up to this. Yeah, you go, okay. I think I know what the problem is asking for now. Do I know how to solve it? Probably not. I mean, one thought I might have is binary lifting, but I feel like that's too crazy. But also just um, the value is 2 times 10 to the 5th. Is that something I can abuse? A 10 to the 5th number of elements. How much time do I have left? I actually don't know because usually I start, at the same time. But here in this particular one, 58 minutes. So I have an hour left. And okay, so node 1 and value 15, you just go up, and I guess that's true. I mean, can you build a try in a weird way? One, two, two. Maximizing, so the thing I would say that is that usually when you want to maximize XOR, usually a try is usually related to a try. Is there anything I can take advantage of this? Because there's only a set amount of possible answers from that. And you have to do it on each node, maybe? Well, what's 2 times 10 to the 5th? 20,000. So that's 16, 2 to the 16, 16 bits. Can we do something 16 bits for each query? Yeah, probably. That should be fast enough, but how do we store it? Okay, so looking up the node is pretty straightforward, probably. But How do we reuse? Can we even reuse answer? This is a hard one. I don't know that I even have any idea. Though 210 pure salvage, though, that's a cheating way of. Each query I mean, this is a hard problem, even if you just give me a list of numbers and not like structured like this. But oh, huh. So one technique that I think I always forget when it comes to queries is that is that okay. Is that you don't have to do queries live, meaning you don't have to pre-process and do the queries because in competitive is cheating. So can we do this recursively? No way. Yeah, we could do this recursively. Then we can just build a trie, and as we build the trie recursively in a depth first search, so it's just a lot of code. So what I would do is we build the trie recursively, and as we do that, we are able to do the queries and do that in a way. Is that weird? Yeah, I think that's the way to do it, though it's really annoying, to be frank. So you build a trie interactively and then process the queries also as you're building that trie, as you're going through that thing recursively. Okay, I think that's the way to do it, but I'm just trying to think whether, I guess that's the way to do it. It's just annoying. That's probably why people took a while. Hmm, it's not impossible. I think if I had pre-win code, and I kind of do have pre-win code, but I don't. Yeah, I also worry that the general thing is too messy. But okay, because so one concern I have, and this is Leetcode specific to be honest, is that, and I've done a similar problem to this in the past, and it's too slow because I had explicit tries and nodes instead of implicit tries and nodes. And I never learned how to do it implicitly because it's really bad code. But in Leetcode, you need it to be performant. So that's why I'm like hesitating a little bit and trying to think about how to implement this in a good way. Yeah, okay. Let me try to think about this, how to, but yeah, so basically, okay, let's just think about it. So now we have some add function. So head is equal to, now just two nodes, right? So none, say, and then now for, okay, I mean, I know how to do this. It's just yucky. Yucky, 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 yucky. Okay, let's just have two functions. Add a number. Yeah, let's add a number, which is what's 2 times 10 to the fifth? 10 to the fifth. Okay, so I actually was wrong about the 16 because I think I missed the decimal. But what is that? 2 to the 15? No, 2 to the 18? 2 to the 18 is big enough, right? So okay, let's choose 18 as the constant. Yeah. So then now we just go, okay. This is just like really, because the problem right now is that I'm trying to optimize, prematurely optimize, to be frank. Um, but what an annoying problem. It's just really, really like, now that I get it, I also know that implementation is a little tricky, but that's fine. I've done it before. I don't know why I'm being a little nutty about it. Let's just say, let's just, so we want the big bit. Yeah, okay. If this is greater than 0, I've written this code before too. That's the sad thing. That means this is a 1, so we want if oh, this is bad. No, this is yeah, okay, fine. If I is none, then has I is equal to oh wait, what am I doing? This is oh no, this is what am I doing? Okay, I'm just being really bad about it. Even though I know how to do it, and hours should be way more than enough time, to be frank. And then current is equal to current minus 1. Okay, yeah. Let's just say j is equal to what? I could probably write this much better, but it is what it is. I think this is good. And then at the very end, I have to set something, don't I, in a better way. This is why I usually have a structure, but okay, fine. Let's just say force, force, currents of 2 is equal to true, something like this. That's why I usually have a structure. I'm writing really ugly code right now, to be honest, but okay. And then now, okay, I'm just going to try my double test my API for a second. I know that there's a lot of things to do. This is a lot of coding, but it's not impossible. It's okay. Let's see if this gives me any error. If it's okay, it's okay. Okay, fine. Let's even print head. This actually, this may be really big because it has a lot of okay, and I'm correct. Why is this? Oh yeah, right. Should have 1, 2, 3, 4. So that's 4 numbers. Okay, I think this is actually maybe what I expect, give or take. Okay, so that's good. Okay, remove is the same. I probably should do a traversal of this. Yeah, remove should be okay. Okay, so okay. But that's not good enough, is it? Because on remove, you need to propagate up to remove. I guess we can have a. I'm like writing such terrible code. Actually, we could just add this to 0. This is none. Then we could. Then there's a path in there, so that's this. Okay, I think this traverse is a little bit bad. It's not a little bit bad, but we need to be more specific. So let's do that. Otherwise, current sub j of 2 plus 1. But I think this should never be the case, so that's fine there. Okay. Okay. Again, I'm writing really bad code, but let's try it again. I'm going to take my time. How much time do I have left? 44 minutes. Okay, add I. Okay, so this should give me no error, and it doesn't, so that's good. Okay. And then now we want the maximizer. I think with the queries is actually okay. So I don't need to do the maximizer yet. Let's build the tree then. Okay. How do we build the tree? Such a weird problem, which is an annoying problem. Because now we want the children, right? So okay, fine. Okay. So children is equal to and then for index parent and enumerate parents, children of index, or wait, no, parent is equal to index, right? I think that's right. Yeah, so 30 means that the 3 is okay. And what's the root? Root is the one where it's -1. Okay, so that's fine. So yeah, root is equal to children of -1 should only have one element. So let's just do that. Okay, let's just sorry. Let's print out children real quick. Okay, so yeah, root 1 is 0, 0, 1, 2. So this looks like that. Okay, 3 is the okay, so the root is 2, and 2 has 3, 7. Okay, so I think this is a good. So I did okay here. Yeah, I think I'm good on the implementation of this children parsing. And then now we have to do recursion on or depth first search on this. So now let's just do a depth first search. Well, let's actually process the queries first. So let's just okay. So for index of query index, query and enumerate queries. Actually, query is node and wire. Okay, fine. Node and wire. So then now we want to set. Let's just. I'm lazy with the name, so let's just do this for now. Yeah. And then okay. Yeah, okay. No, I'm good. I'm just double checking. So Q of the node, when we process the node, we have to process this. Append YU index. I think this is good enough. Okay. So then answer is just equal to an array times the length of queries. And then we return answer. That's good. So then now so we go through the node recursively. DFS of node, and we want DFS the root, which we have the variable for. So here we go, we add node.value, right? Is that, no, well, this isn't a real node, so actually, yeah, we add the node, we want to remove it afterwards, but we want to go for x in children of node, we do DFS of x. Okay, so that's good, but we actually want to do a processing before we do a DFS, and that is okay. Answer queries maybe. Okay, so that means that for value index in Q sub node, we want to get max. This is a terrible name, but that's fine. Get max of value. Answer of index is equal to get max of value. And I think we're done here effectively. But the annoying thing is that I think this is another Leetcode problem, is to get max thing, which is that now we go through the list. So I think it's not that bad, but it's just really annoying, like everything about this problem. And then now, okay, if this is a, okay, let's think about this, right? If this is, why my x? This is, okay, let's just call this an x. Okay, if there's a 1, our max XOR, we want to optimize for 0, right? So if current sub 0, if that value, which is the second value, I know my code is bad, my bad, is greater than 0, then we go down that path. Yeah, and j is equal to, then we go down the 0 path. We want to get the answer. Wait, do we return the max difference or return the number? Find the max difference. Okay, so that means that if this is a zero, if we want to go down the 0 path, then we have a 1 in this digit. So okay, so we do this. Well, no, that's not the answer. Okay, but then j, we want to go to 0. Otherwise, j is equal to 1, and we don't change the answer. Else, if x is digit is 1, if we go to 1, then j we go to 1 and answer right? I think this is roughly right. It might not actually be right, but okay, none object is not. Oh yeah, that's right. I have to check for the none. If current sub 0 is not none, and this is the case, what happens if the entire both path is not 0? Is that possible? No, we always have at least one number, so we should be able to go down one path, right? 225, is that even right? Nope. Okay, we did a lot of stuff. We're happy about it, but not that happy about it. But you know, yeah. Why is this wrong? What is the answer for here? Okay. I don't have a good visualization. I mean, this is not that hard to debug, to be honest, but yeah. Okay. Let's look up here. Look up value, well, index the value, and let's just look up the curve. Oh, this may be a little bit crappy, but curve is not in play, of course not. What is this? Oh, head. This is not going to be that readable, but I think we're close. But yeah. Let's see. The thing is, this is like printed out in a very weird way. So okay, so the second we go 5. Okay, on 0, what happens? On 0, the tree should be on. What is this 0 for? Oh, what is this 0 for? Did I mess this up? Oh, I see. I don't have a number on the top. So I need to increment. I need to increment before this. So yeah, on the root. Does that matter? Shouldn't matter, right? Left, right. Oh, this part. 0 is not none. Yeah, that shouldn't matter. Okay, I don't think that matters, but okay, let's try to let's print it out. Ugh, this is so annoying. Let's see, I and J answer. Okay, so what are we looking at? So okay, so when we look up the 2, no, 2 is the no to we're doing looking up a 5. In this case, we're looking up the 2, so we should have 0, 1, 2. So 0, 1, 2. What? Did I mess up something? I mean, I could have messed up something, but I don't know how I'm printing this out. Okay, so it gets 0, 0, 0, 0, 0. It goes on 0 until it gets the 2, the second digit. Here the J is 0 because for 5 we want to go to 0 because 5 is 1, 1, 0, 1. This is no good, so we still get 0. What numbers do we have here after the 2? The 2 should have 0, 1, 2. So yeah. So the 0, 1, 2. And it should match 0, 1, 2 with a 5, so it should match the 2. Yeah, that sounds right. Yeah, that sounds right. But why do I have... Why does it go 0? Oh, going 0 is right. This should go 1, I think. Because there should be a 2 in there. Dun dun dun. Is my depth first search incorrect? No, it should be okay. The depth first search is pretty good, I think. I feel like I'm close, but okay. Still have half an hour. I'm okay on time in terms of finishing. So ref I, ref J. The answer okay, so we definitely take this digit. We take this one as well. Oh, we don't take 1, but we take the thing. So that means that we're missing the 2 somehow. And we definitely have 3 numbers somewhere, but can I add this to be more debuggable? Let's see. I'm just doing this to be debuggable, but it's going to be a mess, to be honest. I mean, this should be the last element removed, so I think I could just pop that. I could be wrong on this debugging, to be honest. Yeah. 0, 0. Why does this only have 2? Maybe that's actually fine. Okay, 0, 2, 3. Why? What? No, there's no case in which we have 0, 2, and 3, unless I'm adding the wrong number. It should have. Okay, let's look back a second. Coding is so hard, right? 0, 1, 2 is fine. Okay, there's no 0, 3. Maybe I just misread what I was saying. Or maybe I was looking at the wrong thing altogether. So 0, 1, and 2. So that's right. Okay, so let's print that out then. Where's my print? Look up get max. So here we can print out. Oh, am I dumb? I am dumb. I forgot to shift the current. That's why. Okay. Okay. Hopefully, maybe that's it. That is a dumb typo, though. Let's see. Okay. Do I have the right answer? I think I have the right answer. Okay. Wow, I am dumb. Let's now clean up the code a little bit, or my debugging code. I might need it again, to be honest, but we'll keep our fingers crossed and just hope we don't need it again. I have more debugging stuff, but let's get rid of this. Do I? Do I have no more print statements? I thought I have more. Line 4. What did I do? Oh, whoops. Okay, so I think I'm mostly done, but line 27. Oh, how did that happen twice in a row? Oh, maybe auto complete type things auto deleted my bracketing. Okay, so this looks good. Is it fast enough? Probably. If not, then I'm just, I don't know, YOLO. Fingers crossed. I mean, this is okay. Okay. Yeah, ACOTLE. Okay. Let's see. Okay. Where's my ranking? Before I forget, I guess. Yeah, okay. 71st. I don't know if is that like up to date or whatever. That was a hard problem. I mean, that was a annoying implementation problem, but doable. Yeah, so that sounds about right. I mean, I don't know how accurate. I mean, I know that virtual contests don't include the Chinese competitors. So I think hopefully maybe I'm top 100 or something like that. But it doesn't really matter, right? It's an approximate thing. Um, yeah. Let me. So I usually do go over what I think about these. So let me take a quick look. Number 1 and 2 is easy. What is number 3? Maximum points of cost. Oh, uh, how come I'm not okay? Oh, there's the scrolling down. Yeah, I mean, I was just sloppy with. I mean, this is okay, and of course, this, as I said, the left side it is just a max function, so this can get rid of linear. Here, I think there's I think you could put this in a mono. You could put this on a mono queue, I think, but I am. Yeah, I think you can do this on the mono queue, but that's fine. I like contest code. I'm not gonna think about it too much, or I'm not gonna be too sad about it. And this one, I mean, as soon as I realized the trick, which is that we don't have to do the, because to be honest, this is a little bit crappy of contest problems. Is that when you get queries, some of the implication is that you should do them live, like you should get the queries as you get them. But it turns out that very often a trick is that you don't have to do them later, so then you can kind of do them in a different order. But that's like a really weird thing to kind of think about, because on an interview, it just feels weird, right? It almost feels like a gotcha more than anything. So it's always a little bit awkward. But yeah, um, Okay, that's all I have for this contest. Yeah. Okay. Uh, Thanks for watching. Why is the light so weird? Okay, I don't know. I didn't realize I'm so dim, but okay. Yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest. Yeah, stay cool, stay healthy. I will see you in a sec. Bye bye.